On this program, a wide variety of rigging equipment is shown in many different situations. The particular equipment used in various rigging operations is often a matter of company policy. For example, some plants may require safety latches on hooks. Others may require the use of thimbles in the eyes of rope slings. Be certain that you understand and follow the rules in force at your facility.
Safe rigging requires that you understand the equipment you will be using, that you inspect it carefully before using it, and that you know the equipment will safely support the load. Rigging a load safely begins with understanding your equipment. In this program, we're going to take a look at the different types of slings and hardware available for different rigging situations. And we're going to point out some things you need to know about how to select them, how to use them properly, and how to protect them from damage. There are 4 kinds of slings commonly used for rigging: synthetic web, metal mesh, chain, and wire rope. The type used in a particular situation depends pretty much on what the load is and on what the conditions are when the lift is being made. Let's start with synthetic web slings. These slings are relatively wide, soft, and flexible, which gives them a number of advantages. They have good gripping power because they contact the load when they are wrapped around it. They are often used to lift highly polished or painted objects because compared to other kinds of slings, they are far less likely to damage the surface, and they do not rust, so they will not stain the load. Now, these slings may seem to be pretty much alike. However, they are not all made out of the same material. If you are using a synthetic web sling around strong chemicals, even fumes, it makes a big difference whether the sling is made of nylon, polyester, or polypropylene. As a general rule, nylon can be used around most alkalis. Polyester and polypropylene can be used around most acids. But be careful, there are exceptions, and they can hurt you. If you have any doubt about the suitability of a sling, check with the manufacturer. There can also be an important difference in the metal infittings on these slings. Some are steel and some are aluminum. Do not use slings with aluminum infittings around any strong chemicals, acid or alkali. One limitation of synthetic web slings is that they cannot be used in extremely high temperatures. The upper limits given by different standards and manufacturers range from 180 to 200 degrees Fahrenheit. Do not use synthetic web for hot loads or in temperatures that approach this critical range. Synthetic fabrics can melt. And last, you should know that synthetic web slings are affected by sunlight and other sources of ultraviolet radiation. Be careful to store them away from direct sunlight. Metal mesh slings have the same flexibility and gripping action as synthetic web. They are often used when temperatures are too high for a synthetic sling or when the load is rough or has sharp places that could damage a synthetic material. As tough as they are, metal mesh slings can be nicked, gouged, or crushed, especially if they are not handled properly. They can also be damaged by corrosion. Regular cleaning and lubrication will help protect them from the effects of moisture and chemicals. Alloy steel chain has high resistance to abrasion, and it tolerates greater temperature extremes than any other kind of sling. Steel chain is manufactured in different grades for different uses. One of these grades is alloy steel, and alloy steel is the only kind of chain approved for overhead lifting. It is marked at regular intervals with the number 8, or some number containing 8, or the letter A. Like any other material, chain can be damaged by the impact of something dropping on it. When the chain is not being used, do not leave it where anything heavy can fall on it or crush it. One small crack can open the chain the next time it is used. Anytime a chain is going to be stored for even a few days, it should be oiled first for protection against corrosion. But when you take the chain out of storage, wipe the oil off before you use it again. An oily chain is slippery to handle. It can cause loads to shift, and it holds grit, which causes wear on the chain and on the load. Now remember that there are also limits to safe operating temperatures for chain. Whenever you use chain in very hot operations, check the manufacturer's information to determine the effect of high temperatures on rated capacity. You can generally expect that alloy steel will lose strength in temperatures as high as 600 degrees Fahrenheit. Chain from some manufacturers may have to be used at reduced capacity in temperatures of 400 degrees Fahrenheit. Always keep the chain clear of any welding or soldering operation. Wire rope, often called simply rope or cable, is the most common rigging material used in industry. It is strong, flexible, lightweight, and relatively inexpensive. These advantages result from the way rope is constructed. However, the way wire rope is made also increases its potential for wear and damage, including wear and damage inside the rope, where you cannot see it. A wire rope is made up of hundreds of wires of high-grade steel, formed into strands, and laid around a supporting core. These wires will be made of either improved plow steel, called IPS, or extra improved plow steel, called XIP or EIP. XIP is about 15% stronger than IPS. Anywhere from 6 to 48 of these wires are laid around a center wire to form a strand. Then, several strands, usually 6 or 8 of them, are laid around a core. Rope is usually identified by 2 numbers. The first number refers to the actual number of strands in the rope. The second number is a class number, indicating a range for the number of wires in each strand. For example, in a 6 by 19 rope, the 6 means that it has 6 strands, and the 19 means that there may be anywhere from 9 to 26 wires in each strand. In general, rope with more wires is more flexible, and rope with fewer, larger wires is more resistant to abrasion. Ropes are also identified by their lay. Now, the term lay can be confusing because it is used to describe 3 different characteristics of a rope. First of all, it can refer to the direction of the strands around the core. If the strands are laid to the right, you have right lay rope. And if they are laid to the left, you have left lay rope. Now, that's pretty straightforward. But lay can also indicate how the wires are laid in a strand compared to the way the strands are laid around the core. If the wires and the strands are both wound in the same direction, both to the right or both to the left, the rope is lang lay. Lang lay rope is not used for slings. In regular lay rope, the wires are wound one direction and the strands the other direction. It is not as likely to unwind as lang lay rope. You can recognize regular lay rope by the way the wires form a pattern of lines that run parallel to the length of the rope, straight up and down. Wire rope slings are right regular lay rope, sometimes shown in catalogs as RRL. Now, the third meaning of rope lay is a unit of measure. If you trace the path of a strand around a rope, one rope lay is the distance along the rope it takes for that strand to wrap around the core one time. One easy way to determine lay length is to count off the number of strands and measure the distance. For example, if you have 6-strand rope, count off 1, 2, 3, 4, 5, 6 strands along the length of the rope. This is one rope lay. The core of wire rope is generally either fiber or another wire rope. Most rope used for rigging is IWRC, Independent Wire Rope Core. A wire rope's tolerance of temperature varies significantly, depending on whether it has a fiber core or IWRC. You cannot use a fiber core rope in temperatures greater than 180 degrees Fahrenheit, but you can use IWRC rope at much higher temperatures. The wires inside a rope have to be able to move easily whenever the rope is flexed or when tension is applied, so it is important to keep the rope from getting kinked. A kink, or dogleg, weakens wires and interferes with internal adjustments the rope has to make. The wires can no longer slide against each other to compensate for changes in tension and angle. Once a kink gets into a rope, there is no way to get it out, and the rope will have to be discarded. Avoid excessive bending or twisting, and never tie a knot in a rope. Damage can also be caused by shock loading, lifting a load abruptly without first taking the slack out of the rope. Setting the load down too quickly can cause bird caging. A bird cage is created by strands bouncing back and allowing the core to come through an opening between them. For most rigging jobs, you will use factory-finished slings, but there are some situations where you may have to install rope clips to make an eye on the end of a sling. Rope clips are special fittings designed to clamp the end of a rope into a loop to form an eye. Rope clip manufacturers will tell you how many clips you need for the size rope you are using, how much rope to turn back to make the eye, and how much torque to use to tighten the clips. Follow the clip manufacturer's instructions carefully. If you are using U-bolt clips, always install the clips with the U side on the short or dead end of the rope and the saddle on the load-bearing side. Remember the saying, never saddle a dead horse. The saddle part of the clip has grooves in it to fit the strands of the rope for a tighter grip. Place the first clip one base width from the dead end of the rope. Tighten the nuts evenly, alternating from one to the other until you reach the recommended torque. Then, using a steel thimble to shape the loop, install the second clip as near the loop as you can. If more than 2 clips are required, space the others evenly between the first 2. Test the sling with a heavier load than you will actually be lifting with it, and then re-torque the nuts. If you use the sling more than once, check the torque again before each use. For most rigging jobs, you will probably be using some kind of hardware as well as slings. Make sure it is the right hardware for the job, and be sure it is strong enough. Most lifts involve the use of a hook, even if it is only the hoist hook. Be sure the load is centered in the hook. You do not want the point of the hook to bear the load weight. A point-loaded hook can open up on you. One way to protect the hook from point loading is to use a ring or shackle to attach the sling legs to the hook. A shackle is often used to attach multiple sling legs to the hoist hook. The pin of the shackle, not the bowl, should rest on the hook. Washers can be added to the pin to center it and keep it from shifting during the lift. In many cases, eye bolts are inserted into the load as attachment points for the sling. Eye bolts are best used for straight lifts where there is little or no side pull. If there is going to be any angular pull, it is best to use swivel eye bolts, sometimes called hoist rings if they are available. These will turn as required to adjust to the angle of the pull. But if eye bolts are your only choice for an angular pull, be sure they have shoulders. The shoulder must be flush with the surface of the load. Be sure the eye bolt is turned so it is in a straight line with the sling. If necessary, you can use washers to get the eye bolt turned the right way and still have the shoulder tight on the load. Never run a wire rope sling through an eye bolt or swivel bolt. It may create too sharp a bend in the sling. And a hook inserted directly into an eye bolt may bind and become point-loaded. It is always best to use a shackle. If you ever have to rig an odd-shaped load, you may need to make a very small adjustment in one of the legs of the sling. With a chain sling, you may be able to use an approved chain shortener. Or you could use an adjustable rope sling that keeps the load balanced by running across a sheave or set of rollers in an assembly that attaches to the hoist hook. Some operations use turnbuckles for precise adjustment of sling legs, but they are not recommended for routine lifts. They can slip or stretch out of adjustment under load. If you must use a turnbuckle, be sure the threads are fully engaged. Now, whatever kinds of hardware or slings you are using, there are some rules that must always be followed. First, be sure that whatever you are using has a rated capacity greater than the weight of the load it will carry. Never twist a sling, and never tie a knot in it. Lift the load slowly and smoothly to prevent jerking. Do not try to drag a sling from under a load that is resting on it. If the load has sharp edges, use some kind of padding or buffer to round them off. This will protect the sling from being cut or gouged. And in the case of wire rope, it will soften the bend and keep the rope from being kinked. If you are working in extremely hot or cold conditions, check the temperature limitations of the materials you are using. When any sling is not in use, do not leave it where anything could be dropped on it, or where it might be subject to other kinds of physical damage. Store equipment in a clean, dry place where it will be protected from crushing and kinking, chemical damage, moisture, and extreme temperatures. And remember, if you ever have any doubt about a sling or piece of hardware, take the time to check with your supervisor or the manufacturer. Safe rigging starts with using the right equipment for the job.